At the start of the 20th century, the world was advancing rapidly. The Second Industrial Revolution had introduced widespread electricity, the internal combustion engine, and new communication tools like the telegraph. In science, Newtonian mechanics still dominated. Space and time were thought to be fixed, absolute, and universal, unchanging regardless of how fast you moved or where you were. Despite confidence in classical physics, cracks were forming. The Michelson-Morley experiment in 1887 showed that the speed of light remained constant, regardless of Earth's motion, something that Newtonian physics couldn't explain.
So enter James Clerk Maxwell.
Electromagnetic
Maxwell
theory,
set out-
developed by James Clerk Maxwell, hinted at deeper relationships between light and energy, but no one had unified them with motion or mass. Technology like early X-rays and cathode rays were being discovered, but atomic theory was still being developed. Physics was on the edge of transformation. Albert Einstein was born in 1879 in Ulm, Germany. He studied physics at Swiss Federal Polytechnic in Zurich, graduating in 1900. After struggling to find a teaching job, he worked at the Swiss Patent Office in Bern. In 1905, his miracle year, Einstein published 4 groundbreaking papers. One of them introduced the special theory of relativity. Within it, he derived the now iconic equation E equals mc squared. This equation is a direct consequence of special relativity. E stands for energy in joules, m is mass in kilograms, and c is the speed of light, which is a constant.
That mass and energy are both but different manifestations of the same thing. A somewhat unfamiliar conception for the average.
Einstein's special relativity also revealed that space and time are not separate. They form a single framework called space-time, and they vary depending on motion. Time can slow down and lengths can contract at high speeds, concepts known as time dilation and length contraction. Einstein's equation changed physics and the world. It laid the foundation for nuclear power and nuclear weapons, both of which rely on converting mass into energy. It also explains how stars, including our sun, produce energy through nuclear fusion. Relativity impacts everyday technology too. GPS satellites, for example, must correct for time differences caused by both their speed and their position in Earth's gravitational field, as predicted by relativity. On a larger scale, the equation has contributed to our understanding of the universe, from black holes and gravitational waves to the Big Bang. It redefined how we think about reality. The theory of relativity and E equals mc squared marked a turning point in science. By showing that mass and energy are fundamentally the same, and that time and space are not fixed, Einstein reshaped modern physics and opened the door to countless technologies and discoveries that continue to evolve today.